of physics. Basically, the physics of 10th standard has only 4 chapters. In that, we are in 3rd chapter. We have done light, we have done human eye, we have done electricity, done means doing electricity, and we will do magnetic effects. So, before next month, for sure, August end, from my side, syllabus will be done. Once again, I will start from light. I will revise deeply once again. At the same time, those who are coming for Thursday's practice class, they are doing some numericals there from light and human eye still, isn't it? It will continue for this month also. So, the Thursday's class, practice class of physics, is just to make you good in numericals of light and human eye. Because I teach electricity, you should not forget light parallelly. That is the only reason why we have kept this practice class. Okay. If I just recall whatever I have taught in the previous class, then you must remember that we have learnt what is the meaning of quantization, what is a charge and how much is the total charge on the body. Quantization is N into E, where N is the number of charged particles, E is the basic elementary charge. It means how much charge you have by this many protons, this many electrons can easily be found if you multiply the number of charged particles with charge carried by each particle. So, by now you must remember or you must know that if you have one electron or one proton, it carries a charge of plus or minus 1.6 into 10 to the power minus 19 coulombs. What is this? Charge carried by an electron or a proton. If I am having 10 protons, then I will have 10 into each charge, isn't it? So, this formula, which is equal to Q is equal to NE, gives us total charge created by a given number of charged particles. I said in the previous classes to you that if the charge starts to move, it creates current. So, what is current? It is the flow of charge, rate of flow of charge. Q is equal to I by T, sir, ulta I wrote, I is equal to Q by T. Current is charge per unit time. It means if you have a proton, it starts to move, the current is produced. If you have an electron, it starts to move, current is produced. Difference is current produced by a moving proton and a moving electron will have different directions. Current produced by a moving proton will be in the same direction of proton. Current produced by moving electron will be in the opposite direction of electron. This current is called as conventional current. This current is called as electronic current. Conventional current and electronic current. Then I could tell to you how the questions can be asked from this topic. First kind of question I said to you was, they may ask you whether this much charge is possible or not. They will give you Q and they will ask you whether it is possible or not. How you will check it? You will divide Q by E, what do you get? You get N, and if N is a integer, then that charge is possible. If N is a fraction or decimal, it is not possible. That is, if you divide Q by E and you get the answer as some decimal number, then you can very boldly say that that is not possible itself. But if you get a integer, then that charge is possible. Because it is like meaningless to say that we have 2.5 electrons. What is the meaning of 2.5 electrons? Electrons can either be 2 or it can be 3, it can be 2.5. It's not apple that you can cut and have half part. Electron, we cannot have half electron or 1/4 electron. So, N should be an integer. Then we learnt the concept of potential difference. I said you, potential difference is very similar to how a tank in a home works. That is, if you have tank on the terrace and you open the tap, the water comes by itself in the tap. Why? Because tank is at higher potential and tap is at lower potential. When you open the tap, water automatically flows because everything has a tendency to flow from higher potential to lower potential. Potential difference is the same thing. It creates potential for the charge to move. So, I gave you an example like if you take a metallic plate, suppose I am taking aluminum plate. If I ask you whether aluminum plate has free charge particles, the answer is yes. Aluminum is a conductor, it is a metal, and by now you should know that metals or conductors have free electrons on their in them. That is the meaning of metal itself. They can conduct electricity. Why? Because they have free charged particles. If there are free charged particles, are they at rest? No, they are in constant motion, but they are moving in random direction, not in same direction. That is the reason the net current is 0. If you want all the electrons to move in a particular direction, then I must connect it with a source of potential difference. The moment I connect it to a source of potential difference, there is a potential difference created which is higher potential and lower potential. So, when you have a 1.5 volt battery, suppose I am buying a battery which is a 1.5 volt, you know what is the meaning of it? Meaning is positive terminal is at 1.5 volt and negative terminal is at 0 volt. That is why the potential difference between them is 1.5 volt. If somebody says, no sir, I will say like it is 3 volt, it is 1.5 volt, they are also correct. Because once again when you do a difference, 3 minus 1.5 is 1.5 volts. So, 1.5 volt is the potential difference between the terminals of a battery. And what is the meaning of that mathematically? Potential difference is defined as work done per unit charge to move it across the circuit. Work done per unit charge. Work done is in joule, charge is in coulomb, joule per coulomb will be in volts. And from here we can define what is 1 volt potential difference. This will come in the examination. Define 1 volt of potential difference. 1 volt is the potential difference which like if 1 joule of work is done to move 1 coulomb of charge from one point to another point, the potential difference is 1 volt. I have defined in the class. Then in the previous class we learnt about something called as Ohm's law, where a famous physicist, his name was Ohm, he has made a relationship between what and what? Between voltage and current. So, what he did an experiment. In that experiment he connected, there is a circuit like this, he connected a ammeter here, he connected a voltmeter here, and then he tried to measure the values of potential difference and current for different batteries. 1.5 volt battery, 2.5 volt battery, 5 volt battery, 6 volt battery, 9 volt battery, 10 volt battery, different batteries he put here, and he checked what is the value of V and what is the value of I. When he checked all these values and he drew a graph, that graph was a straight line, which indicated that V is proportional to I. Potential difference is proportional to current, and that is how we define Ohm's law. If you remember, the Ohm's law I have defined as potential difference across a conductor is directly proportional to the current flowing through it at constant temperature and physical condition. Yes? So, if the temperature is constant and the material is constant, then the potential difference is proportional to I. If you remove the proportionality, you have to add a constant, and that constant is called as R. And this is how we define resistance. What is resistance? Resistance is defined as V by I, that is volt by ampere, called as ohms. Ohm is how we represent the resistance. Unit of resistance is ohms. Then in the previous class, you learnt what are the factors on which the resistance depends. Very important topic, very important topic. Expect a question to come definitely from here in the board examination. What topic? Factors on which resistance depends. I told you resistance depends upon 4 factors. Resistance depends upon the length of the conductor, resistance depends upon the area of cross section, resistance depends upon type of material, and it also depends upon temperature. So, there are 4 factors on which the resistance across a conductor is depending. If you have 2 wires of different length, same area of cross section but different length, if this is L1, this is L2, R2 will be more than R1. It means longer the wire, more is the resistance, which very clearly indicates that R is proportional to length. A longer wire will have more resistance. I told you the reason for this also. The reason is, remember this to you in your mind. Resistance is created because of the collision of the electrons inside the conductor. So, if the electrons are moving in the conductor and they are hitting with each other, then this collision between the charged particles, that only creates what? That only creates the resistance. So, resistance, if we have two wires and both wires are having different lengths, it means a longer wire has more electrons and it has more chances of colliding. So, it will have more resistance. It is very common sense, please pay attention. If you have two wires, 1 meter long, 2 meter long, 2 meter long wire is more longer, so it will have more electrons. If it is having more electrons, there are more collisions possible, so it will have more resistance also. That is how you should remember. And what about the area of cross section? If you have two wires, one wire and second wire, they both have same length, but here the area of cross section is A1, here it is A2. So, we found that A1 had more resistance than A2, that is, if I write in terms of R, then R1 was more than R2, which clearly indicates that resistance is inversely proportional to area of cross section. How to understand this? Same concept. If it is having more cross section, it has more space. If it has more space, electrons can move freely. If electrons can move freely, the chance of electrons colliding will reduce. It means it will have less resistance. But if you have a thinner cross section, less space for the electrons to move. Less space for the electrons to move, it means they will collide more frequently. If they collide more frequently, it has more resistance. So, resistance is inversely proportional to area of cross section. Less area of cross section will make more collision of electrons, more area of cross section will make less collision of electrons. Because more area, you will have less chances of colliding, isn't it? I told you, in a road, if you are driving a cycle and there are thousands of cycles in front of you, car, cycle, bike, everything, then when you are going, you may have chance of going and hitting some other cycle or bike, right? But if you are riding on a free road, then you easily can go without colliding with anybody else. So, same way, if you have a thinner cross section, you may have more collisions because there is less space to go. But if you have a bigger cross section, you have more space for the electrons to move, collision will reduce. If collision is reducing, resistance is reducing. That is why resistance is inversely proportional to area of cross section. A bigger cross section will have a smaller resistance. When I combine both, then I write R is proportional to L by A, and R will become equal to rho into L by A. Now, what is this rho? Resistivity. It is defined as resistivity. So, resistivity rho, what unit it will have? If I write R into A by L, R is in ohms, meter square by meter, meter gets cancelled. So, SI unit of resistivity will be what? Ohm meter. Everything we have learned in the previous, I am just revising everything. Everything we have learned in the previous class itself. And third factor is type of material. It means, obviously common sense this is, if you have gold and if you have aluminium, do you think they will have same resistance? No. How? Different materials will have different resistance. Fourth factor is temperature. Temperature increasing will definitely affect resistance. Why I am saying? Because if there are more temperature, electrons will have more energy. If it has more energy, it will vibrate more fastly. If it vibrates more fastly, chances of it to go and hit some other electron is once again increasing. So, increasing temperature will increase the resistance, decrease in temperature will decrease the resistance. Not only that, I told you resistivity is independent of length and area of cross section, but resistivity depends upon type of material and temperature. So, if they ask in the board examination, what are the factors on which resistivity depends? What is the answer? Type of material and temperature. If they ask you what are the factors on which resistance depends? Length, area of cross section, type of material and temperature. That is the reason why do we classify the materials based upon resistivity and not based upon resistance. if I start classifying materials based upon resistance, then 1 meter of copper and 2 meter of copper have different resistance. 1 centimeter square of copper and 1 millimeter square of copper have different resistance. So, we cannot classify what do you say, the materials based upon resistance. So, when you go to higher classes, when they will classify materials as conductors, insulators, semiconductors, superconductors, this classification will be done based upon the metal's resistivity, not resistance. I hope you get why. Because resistance of two wires of same copper itself will not be same if they are having different length or different area of cross section. But resistivity is independent of that. 1 meter copper, 1 centimeter copper or 1 kilometer copper, whatever copper you have, it will always have same resistance. That is why resistivity, I mean. That is why we classify the material based upon resistivity and not based upon resistance. Also, in the previous class, we did some questions from here. I said you will get a good amount of questions from this topic, where they may say that if length is tripled, if area becomes half, how will the resistance gets affected? Take one question now. All of you take one question, please. Question is, how will the resistance of wire get changed? How will the resistance of wire get changed? How will the resistance of wire get changed if it is compressed, to half its radius, if it is compressed to half its radius, if it is compressed to half its radius. Tell me fast. If it is compressed to half its radius, give a try. Solve fast, tell me fast. Got the answer? Darshini, welcome at 6:30 p.m.
should we change that also or only the
Preetham, good question, and it is a common sense. Imagine there is a wire whose radius is becoming half. How it will happen? I told by compressing, isn't it, Preetham? So if area will reduce, what will happen to length? It must increase, conservation of volume, right, Preetham? So if you are not minding that, you will not get the answer. Remember this thing. Until they mention, I will give a question from that category also. I will solve one question today where you may not have to do this what I am doing here. Because what they will tell, they will say there is a wire of length 1 meter, there is another wire of same material of 3 meter length. In that case, you will not take area is also changing, but the same wire is compressed or elongated. In that case, you must understand that after elongation, what happened? Area became less, but the length became more. So in this case, let the area be A and the length be L, or A1 and L1. Here it will become length as L2. What will be area? A2. If the volume remains same, can I write A1 L1 is equal to A2 L2? What is the area 1? Pi by 4, or they are talking about radius, right? So I can write pi
the area will be
pi r1 square.
1 by 4 times
Pi,
smaller and the length will be 4 times larger.
let us check that. Pi r1 square into not A, it will be L1, right? Is equal to pi. What is the R2 value given? Half of R1, isn't it? So pi gets cancelled. R1 square into L1 will become equal to R2 is given as R1 by 2. They told R became half. Here the radius is R1. Here it will become R2. And they are given the question R2 is equal to R1 by 2. Now R1 by 2 whole square into L2. So you are going to get R1 square into L1 is equal to R1 square by 4 into L2. This 2 gets cancelled. You are going to get L2 as what? 4 times L1. So you got the relationship between the area. What is the area relationship? Here what is the area? A1 is equal to pi R1 square. Here what is the area? Pi into R2, which is R1 by 2 the whole square. Am I right? So what is the area here? Area here is pi into R1 square by 4. It means it is A1 by 4. Do you agree with me? So I got the value of A2 as A1 by 4. I got the value of L2 as L1 by 4L1, isn't it? And with this, I can easily find now, in the case of rho, that is, I'll write like this, R2 will become equal to rho into,
Resistance will be 16 times.
let us check here. Yeah, I think so, you are correct. So R2 will become equal to rho into what is L2? L2 is 4L1. What is A2? A1 by 4. So R will become equal to 16 times of rho into L1 by A1. What is rho L1 by A1? R1. So R2 you are going to get 16 times, as Preetham is saying correctly, it will become 16 times of R1. 3-mark question in the board examination. 3-mark question in the board examination. Many students will do mistake in this. Out of all the students writing in the country, 20% students will only write it correctly. Why? Because what they will do, they will think R1 is reducing, no? They will just change the area, they will not mind the length, and they will do mistake. I hope you are getting my point. Anybody has doubt in how I have solved, you can ask me. I have used, I'll explain this again. Pay attention, Kirtikeshwaran. In the question they told that there is a wire which is compressed. If its radius is reducing by half, what is the change in resistance going to take place here? That is the question. Am I right, Kirtikeshwaran? Am I right?
Yes, sir.
Yes. So what I am doing, I can understand that when the wire will be compressed, it will become thin, so it will become long also, isn't it, Kritikeshwaran? So if it becomes thin, it must become long. So we want to find what is the relationship of the new length with the old length. For that, I am using the concept of conservation of volume. So initial volume will be area of cross section into height. I hope you know that cylinder volume is area of cross section into height. So it will be A1 into L1, and in the case of these two wires, the volume will be same. It means A1 L1 is equal to A2 L2. So if A1 L1 is equal to A2 L2, then A1 value is pi R1 square and A2 value is pi R2 square. They have given the value of R2 as R1 by 2. I put in the equation, I get the value of L1 and L2 relationship as L2 is 4 times of L1. So already I had A2 is equal to A1 by 4. I put both the values in here in this formula and I get the value of R2 as 16 times of R1. I will give another question, Kirtikesh student. You try that question, then you will have more clarity. Okay. So anybody else has any doubt in this question? Renit, now only entered inside. Got understood the question that I solved? I will give another question now. Shall I give? Shall I give? Take the question. Make it fast, please. Don't take much time. Time is already 6:40. Today's topic I have not even touched now. Series in parallel. Please, shall I proceed further? Can I go to the next page? Fast. Which step? This step. Here. How this came, you're asking? How this step came, you're asking? Very good. I hope you are asking how this came, right? Oh, below this how it came. That is more bad. Because area of cross section is A1 here. A1 is pi R1 square. And what is area of 2? Pi R2 square. So pi R1 square into L1 is equal to pi R2 square into L2. Pi pi gets cancelled. R2 is given as R1 by 2. I am putting here square of that. So R1 square and 2 square will become 4. So R1 square gets cancelled. L2 become 4 times of L1. Got it? Sure. What? Shakil, shall I go to the next page? And your partner, Darshan, what is the name? Darshan only, no? Yeah. Take this question, NCERT question, give a try. Or let me ask from here. Not required to write the question. Please don't waste your time in writing the question. The question is this, 11.6. 11.6 example. Don't write the question, just solve it. Don't see what is there in the answer. Solve it by yourself. Be careful. Here they have taken another wire itself. So there is no need of applying the conservation of volume. Are you getting my point? If the same wire is elongated, compressed, then only you will apply the conservation of volume. But if you take one wire, another wire, then there is no need of conserving the volume. Try this question, then you will understand. Give a try, please, fast. I hope you are able to hear me now.
Yes, sir.
Yes, so I said in the first wire, they have given the value of length as L, area as A, and resistance is given as 4 ohm for that. Then they are saying what would be the resistance of another wire of same material. Same material means what is same? Resistivity is same. Having length L by 2 means small length, and area of cross section 2A. It means it is thicker also and smaller also. So this will be 2A and this will be L by 2. They are asking what is its resistance. This is the question, isn't it? Let this be R dash. Am I right? So can I say that L dash is given as L by 2 and A dash is given as 2A. So what will be R dash? R dash will be rho into L dash by A dash, which will become equal to rho into what is L dash? L by 2, and what is A dash? 2A. Now what will happen to it? R dash will become equal to 1 by 4 times of rho into L by A. Do you agree with me? What is rho L by A given? 4. R value is what here? Rho into L by A only, no? Rho L by A is given as 4. So what will be R dash? R dash will become equal to 1 by 4 times of 4. How much is that? 1 ohm. So R dash will become 1 ohm. Is it clear to you? I will repeat once again. See, I am repeating it once again. Please pay attention. I am coming to the board and repeating. So what is given in this question? They gave a wire and they said that its length is L, its area of cross section is A, and its resistance is equal to 4 ohm. What is the formula of resistance, Joshita? R is equal to rho into L by A. This is only given as 4 ohm, right? Yes? Okay. Another wire is taken, same material. It means what is same? Here resistance is rho, here also it will be rho. So another wire, same resistivity because same material. Length is how much? L by 2. Area how much? 2A, right? What will be its resistance formula? Rho into L dash by A dash, that is equal to rho into L dash, L by 2. And what is A dash? 2A. Do you agree with me? So R dash became equal to 1 by 4 times of rho L by A. What is rho L by A? 4. So R dash is equal to 1 by 4 times of 4. 4 gets cancelled. What is R dash? 1. Good, Preetham, you are correct. I hope you are understanding what we have done on the board. This is the level of question which comes from this chapter, and expect it to definitely come in the examination. Whether we keep the exam, in your school they keep the exam, or the board exam will happen. Everywhere this pattern of question is going to come. Either if they give same material is stretched, then use conservation of volume. If they give another wire of same material is taken, then no need of making the length, double area, all these things. The volume conservation concept should not be used. Are you getting my point? These things are very important, and questions in physics will come from numericals only. It is not theory, not like biology. You have to get a numerical, you have to solve the numerical. Out of the 27 marks in the board exam, if I am right, 27, 26, how much is the marks for physics? Not knowing that. Whatever it may be, 27, 26 only it will be. It is going to be at least 18 marks of numericals. Possibility is there. I am not saying surely, but possibility is there. Out of 26, 27 question, 17 to 18 marks of numericals may be there, So if you are not knowing numericals, literally you will fail in physics. So there is no escape. Don't think I will just learn theory and go. No way. You have to understand the numericals. That's why we are keeping separate class for numericals itself, if those who are having problem in numericals. Okay, let us start today's topic. Up to now we are just revising the previous class. Time is itself over now. And today's topic that I planned to take was resistances in series and parallel. Give the heading as resistances in series and parallel. Let us see what is that. Resistances in series and parallel. Okay. So we know that, I hope you know that This is how we represent resistance, isn't it? You know why? Yes. Yes, speed breaker. It means that electricity is going to come and it's going to become slow here and once again go. That's why we give this shape itself. It indicates that current is becoming slower over the region. Remember that. Resistance will never stop the current. Resistance will always make the current slower to make it slowly pass through it. Okay. So, there are two kinds of connection we give to resistance. One is called as series connection, where we are going to add resistance like this in series. Let me assume R1, I will give time for writing, please pay attention, R1, R2, R3. Another type of connection is called as parallel connection, where I will add them like this. Understanding? I took one resistance, another resistance, added together. This is called as parallel connection. And if I add one after the other, it is called as series connection. Series connection and parallel connection. Now, imagine some current enters inside, current let it be I. You may assume any value, suppose 10 ampere current comes, 10 ampere comes. 10 ampere, suppose here we have, just assuming, I will erase it later, assuming that 10 ampere current is coming and here you have 2 ohm, here you have 6 ohm, here you have 10 ohm resistance. How the current will behave in all the resistance? If it goes, in 2 ohm it will become slower and go, in 6 it will become further slower and go, in 10 it will become very slow and go. But 10 ampere, if I check here, if I check here, if I check here, same 10 ampere only will go, am I right? 10 will not become 6 or 5 or 4 or 2. What current comes, the same current has to come out. Only thing is, a bigger resistance will make it more slower. A lesser resistance will make it less slower. But resistance work is to oppose the flow of current. Opposing means stopping it. So, in series connection, what I meant to say to you is, this current remains same. But now, I just took some values, some values of this thing, current, like 10 ampere, 10 ampere and 10 ampere, okay. If I ask you, what is the potential drop here now? V is equal to IR, I is 10, R is 2, how much is that? 10 into 2 is 5. V is equal to IR, I is 10, R is 2, 20. IR, 10 into 6 is IR, 10 into 10 is, what happened? Current remained same, potential got divided. Divided means different potential. Are you getting what I am trying to tell? Whatever current came inside, out of which same current only came outside. Since we have different resistances, 2 ohm, 6 ohm, 10 ohm, when you multiply I with R, here you get 20 volt. When you multiply 20 with 6, it will get 60 volt. 10 with 10, you get 100 volt. So, in series connection, the current remains same. The potential difference is I should not say, maybe I should say. Why I am saying maybe? Suppose it is having 2 ohm, 2 ohm, 2 ohm, what will happen? 20 volt, 20 volt, 20 volt. So, if it is different, so potential difference will be different for different resistances, for different resistances. Do you understand what I told now? If the resistance is same, current potential difference also will be same. In the case of parallel connection, imagine current is coming, suppose I current is coming, and let me assume the current value is anything 10 ampere once again. Now current, will it go same current or it will get divided? divided, because there are three paths. Some current will enter here, some will enter here, some will enter here. Okay, you may ask, on what basis it will divide? Common sense. Which path has more resistance, less current will go there. Which path has less resistance, more current will go there. It is not like if there are three paths, it will divide 3.3, 3.3, 3.3, not like that. It is purely based upon resistance values. Yeah, suppose it is 2 ohm, 2 ohm and 2 ohm, then out of 10 ampere, 3.33 will go here, 3.33 will go here, 3.33 will come down, equally divided. But if you have 2 ohm, 5 ohm, 11 ohm, like different resistances, which path has more resistance, less current may go. 1 ampere only may go here, 3 ampere may go here, 6 ampere may go here. So, current gets divided based upon the resistance. So, in the case of parallel connection, what will happen? Current will be different, or I should write current gets divided, whatever you want to write. Current gets divided based on what? Based on resistances. And you will be surprised to know that it is true also, between this point and this point, potential difference will be same. When you multiply IR1, that is here I1 will go, here I2 will go, here I3 will go, right? Different currents. I1 R1, I2 R2, I3 R3 will always be same. So, they will divide in such a way that I1 into R1, I2 into R2 and I3 into R3 will always be equal. It means what is going to be same? Second point is potential difference across each resistor will be same. What you are understanding from here? In series connection, current remains same, potential difference is different. In parallel connection, current remains different, potential difference remains same. If you are understanding, please copy it first. Then I will explain once again to you. I will explain once again to you. Please copy this. Don't write this values example. Just to explain, make you understand, I wrote this. Written. Written. Pratap, you can wait for some time. This is 10th class. You can be here also if you want, your wish. Or you can drop and come back at 7:15, completely your wish.
I'll stay, sir.
Okay. Have you copied, guys? Now please, I'll just take 2 more minutes before I wind off my class. Preetham, Rayan, can I go to the next page? Nitin, Darshini, Mridini.
1 minute, sir.
Make it fast, please. Are you done? I'll continue in the next class because already time is 7:02. So I'll wind off here and I'll continue the same topic in the next class. Okay? After copying, you can